Hello students, today we are going to study a new chapter, General Principles and Process of Isolation of Elements. My dear students, we are living in a materialistic world. That means we can't even think about a world without metals. When we look around us itself, you can see lot of applications are there from metal industries.
The utensils that we are using for our household purposes. The buildings are also using metals. Automobiles, its body parts, its engine, everything is made up of metals. Ships are using a vast variety of metals in it. Electric lines are also using metals. Bridges. Batteries also contain metals in it. Jewelries, gold, platinum, silver. Even precious gemstones are having metals present in it.
So from what are we getting these metals? Some metals are existing in our world in the free state itself. The free state itself, it is existing in our earth. But there are certain metals which is existing in the combined form. It will combine with the other elements and will existing in the form of a compound. So sometimes these elements, these metals we are getting in the from our earth itself in the free state itself, but still it will contain lot of impurities present in it. So we need to make that particular metal pure so that we can use that particular metal for making any of these things, right? So all these processes means the extraction of metals and purifying that metals, everything is coming under a one term that we call it as the metallurgy.
So here comes the importance of metallurgy. A metallurgist connects the science with the technology of metals. So metallurgy includes the extraction of metals, its purification and making it useful for others. How can we define metallurgy? The scientific and technological process used for isolation of the metal from its ore is known as metallurgy. So it includes everything for the extraction, purification of the metal. Ores and minerals. What are ores and minerals? That we can look at right now. Minerals are naturally occurring chemical substances in the earth's crust and is a combined form of any metals. So minerals are naturally occurring chemical substances which is present in the earth crust itself, and it will be of any of the combined form of any metals. It will contain any metals in its combined state. So we are extracting metals from the minerals itself.
Ores. Ores are those minerals from which the metals can be economically and commercially extracted. That means we cannot extract the metals from any of the minerals. So those minerals which are rich in a particular metal, from that mineral only we can extract the metals. So such type of mineral which are rich in a particular metal, we call it as the ores. For example, aluminium. Bauxite is the principal ore of aluminium. Hematite. Hematite is the ore of iron. But it is more important to note that all the ores are minerals itself. All ores are minerals itself. But all minerals are not ores. That means all the ores will be minerals, but from all the minerals we cannot extract the metals. So only those minerals from which we can extract the metals, we call them as the ores.
what are gangue? Gangues are the impurities present in minerals. So minerals may contain lot of impurities present in it. Such impurities we call it as the gangue. We can now look at some facts about the metals. A few elements like carbon, sulfur, gold and noble gases occur in free state while others are found in combined forms in the earth crust. So some elements are occurring in free state but some others are occurring in a combined form.
Aluminium is the most abundant metal in the earth crust and third most abundant element in earth crust. So aluminium is the most abundant metal and third most abundant element. Many gemstones are impure form of aluminium oxide. Gems, rubies and sapphire have chromium and cobalt as their impurities. Now we can look at the principal ores of some important metals. Aluminium. The ore of aluminium is bauxite or kaolnite. Iron, hematite, magnetite, siderite or iron pyrites. Copper, copper pyrites, malachite, cuprite, copper glans. So these are the ores of copper. Zinc, zinc blende, calamine and zincite. So these are the principal ores of some important metals. So in this chapter we are mainly studying about how we can extract the metals, how we can get the metals and how we can purify it. How we can purify the impure metal and certain uses of certain metals also. Uses of certain metals like aluminum, copper and all. Okay, so we can watch today's video.
Now, so we are extracting the metals from the ores. So there are certain steps involved in it. What are the different steps involved in the extraction of metals from a particular ore? So the first step is concentration of the ore. Second step is isolation of the metal from its concentrated ore. And the last one is purification of the metal. So the first step is concentration of the ore. Second step is isolation of the metal from its concentrated ore. And the third step is purification. So in the first step, we will be removing all the impurities present in the ore. In the second step, we will isolate or we will extract the metal from the ore. And the third one, we will purify the impure metal. So these are the three steps involved in the extraction of metal. So we will study in detail about all these three steps.
Extraction of metal from its ore involves three steps. Step 1, concentration of the ore. Step 2, isolation of the metal from its concentrated ore. And the third step is refining of the metal. Normally, an ore contains a metal in its combined state and other materials like sand, clay, etc. will be present in it. So these extra materials we call it as the impurities. We collectively call it as the gangue or matrix. The removal of the gangue from a metal, we call that process as the concentration of the ore, or we call it as a dressing or benefaction. Concentration of the ore can be done in any of these methods: hydraulic washing, magnetic separation, froth flotation, or leaching. The choice of the technique used for the extraction of metal depends upon the difference in the physical properties of the compound of the metal present and that of the gangue. the type of metal and the facilities available. And it also depends upon the environmental factors also. Now we can study the first method, hydraulic washing. Hydraulic washing, we in hydraulic washing process, an upward stream of running water is used to wash the powdered ore. So when a stream of water runs through the powdered ore, the lighter gangue particles are washed away and the heavier ore particles will be left behind. Since this method is based upon the difference between specific gravities of the ore and the gangue particles, we call hydraulic washing method as the gravity separation also. Magnetic separation. So this method is based upon the difference in the magnetic properties of the ore and the impurities present in it. If either the ore or the gangue is attracted towards a magnetic field, then we can use the magnetic separation for the concentration of the ores. For example, for separation of iron from the ore hematite, we can use the magnetic separation. Here, the iron can be attracted towards the magnet while the impurities present in it won't be attracted towards the magnetic field. So the powdered ore should be dropped over a conveyor belt which moves over a magnetic roller. So this is a magnetic roller through which the powdered ore is rolling. So when the powdered ore moves through the magnetic roller, so the magnetic particles, those particles which are attracted towards the magnet will get sticked over the magnetic roller and hence will be deposited on a container. And the other particles which are not attracted towards the magnetic field will be collected in another container. So thus we can separate the two particles depending upon the difference in their magnetic field. So the next method for the concentration of the ore is froth flotation method. So we can use the froth flotation method by the principle that the mineral particles or the ore particles can be wetted by the oils while the gangue particles are wetted only by the water. So we are using this principle for the froth flotation method. So only the mineral particles will be wetted by the oils while the gangue particles by water only. So in this process, the ore should be crushed and we should make a powdered ore, and this powdered ore should be mixed with the water along with the substances known as the collectors and froth stabilizers. So along with the collectors and froth stabilizers, we will mix the water and the powdered ore. And what is this collector is that collector will enhances the non-wettability of the ore particles. We have studied that the ore particles is wetted only by the oils. So normally the collectors will be type of oils itself. The normal collectors that we are using is pine oils, fatty acids, etc. So these collectors will enhances the non-wettability of the mineral particles, and the stabilizers are also being used. The stabilizers are the substances which increases the stability of the froth. Froth means when we are doing this experiment, a froth will be formed over here, and this stabilizers, for example, cresols and anilines are the normal stabilizers that we are using. It will stabilizes the froth which is formed over here, and we will mix this we will mix it with a rotating paddle. So we will agitate it using a rotating paddle. So when an agitation is going on, air will be drawn inside and the froth will be formed over here. And what is this froth will do is, this froth will carry the mineral particles. So froth is very light. We know that froth is really light, and we can skim it off and we can dry it and we can recover the ore particles from it. This is similar to the separation of butter from the buttermilk using an rotating paddle. Normally, we are using this method for the removal of gangue particles from the sulfide ores. The same process will happen over here. The froth bubbles will carry the sulfide ore that we can dry and recover it. This method we can even use for the separation of two sulfide ores. For the separation of two sulfide ores, we need to use a substance known as depressant. What is the role of depressant is that depressant will allow only one ore, one sulfide ore to enter into the froth. For example, if you are going to concentrate the ore which contains zinc sulfide and lead sulfide, both are sulfide ores itself. So we can use a depressant known as sodium cyanide over here. This sodium cyanide is a depressant. So this sodium cyanide will allow only one of the ore to enter into the froth. So in this particular case, it will prevent the zinc sulfide from coming into the froth, but it will allow only lead sulfide to come and enter into the froth. So thereby we can separate. So froth can be recovered and we can dry it and we will get our lead sulfide and zinc sulfide as a separate one. I hope you have understood these three methods of the concentration of the ore, that is hydraulic washing, magnetic separation and froth flotation method. The leaching is the next method used for the concentration of the ore that we will discuss in the next video.